a great day it is to learn science. So buckle up and let's start our lesson. Today we'll be tackling about the scientific method. Have you heard of it? Well, to better understand it, why not answer these questions first? Did you ever ask yourself or anyone, why do I need to eat breakfast? Or maybe ask, how do fertilizers help vegetables grow? Or, how can I recycle plastic bottles and help the environment? Some of us were curious enough to ask these questions. Maybe some of us didn't, but I think we're all intrigued if putting Mentos on Coke really triggered a reaction. Or, why is the water from the beach cold even if it's bright and sunny? Now, by asking these questions, we're actually performing the scientific method. See, scientific method is a simple guide that helps us to move to where we want to be. Like a roadmap, we follow it to get to our destination. So, what do we do first? Well, to be able to ask those previous questions, what we did is make an observation. Quite possibly we went to the beach, and as we were swimming, we felt that some part of the water is warm while the other parts feel cold. Or, you go into your garden and you see some vegetables growing faster than others and observe that some have fertilizers and some don't. Every day we encounter lots of things that makes us curious. It can be the usual things like observing your metal windows are now rusty, or some things out of the ordinary like seeing green-colored flame in science class. So the first step in the scientific method is noticing phenomena around us, or making observations. This is what happens with Sir Isaac Newton. He was sitting underneath an apple tree when an apple hit his head. Now after a couple of observations, he thought, why do apples fall downward? And same with other objects. That is when he formulated a thought, that there must be a force that pulls things downward, and that's what we call nowadays as gravity. Now, first Sir Isaac Newton made an observation, after which what did he do? Yes, he asked a question. This is the second part of the scientific method. We need to be able to come up with a question to have an idea on what we really want to investigate. Thirdly, what did Sir Isaac Newton do after he asked the question? Yes, he made a prediction or hypothesis. Hypothesis, as some say, is a scientific guess. However, it's actually more than just a guess. Before making that hypothesis, what you did was to carefully observe. You made a couple of observations, and based on those observations, you made an inference, a possible scenario. This is what makes hypothesis different from a guess. You are not just speculating, you were observing all variables. Just like Sir Isaac Newton, he made careful observations, he asked a question, and made a prediction based on those observations. You can also make a hypothesis. Say we go back to your garden. You see that your mom put fertilizer on one part and the rest weren't having any. Or maybe you see your dad pour rice water on some tomato plants and observe that within your garden, some plants of the same variety grew differently. Then you make a prediction that using fertilizers will make the plant grow at a faster rate. Now we have our hypothesis. This time, we need to know our variables. Variables are the things that can potentially affect or influence an outcome of an experiment or situation. There are two types of variables. We have the independent variable, that is one being manipulated or controlled, and the dependent variable, the one that changes based on the independent variable. Going back to our scenario, we said that some of our vegetables, although they are of the same kind, grew faster than others. We then ask what made them grow faster. We saw some are given fertilizers and hypothesized that putting fertilizers makes plants grow faster. The next thing we do is to know the other factors aside from fertilizer that makes plants grow. We have its exposure to sunlight, the amount of water we use, the soil we plant it in, can also influence the growth pattern of the plant. Now we see that we can control all these four factors, so we call them independent variable. And the growth of the plants, which differs depending on the presence of these factors, is what we call the dependent variable. Now our next step will be to conduct an experiment. This is one of the exciting part. We get to test if our hypothesis is right. Here it is best if only one of our dependent variable is changed. Here is our list of variables. Now let's observe our hypothesis. We said that the fertilizers is what prompted the plants to grow faster. To test this, we need to make sure that the other variables are the same. So we create two setups. We have set A, where we don't put fertilizer, and set B, where we put fertilizers. We use the same variety of vegetable. We make sure they have the same amount of water given and the same sunlight exposure. Also, the same soil use. We can even create a third set to see if organic and commercialized fertilizers make a difference. Then, we record our results. We make sure that the height of the plants in each setup every day is recorded. We note down their changes in each setup and go back to see if our hypothesis was right. Finally, we draw conclusions. Here we sum up the things we did. From our observation, to our prediction, to our setup, experiments, then what our record shows, and lastly, make a conclusion. If we based on the table, we can say that the use of fertilizer actually affected the plants. It made them grow faster, and this is how we perform the scientific method. Like I said, the scientific method is only our guide. We can alter this or the steps as long as we get to where we want to be, or to what we want to investigate. Remember that a great scientist always values truth, so regardless if our hypothesis was not on point with the result, we still need to report the facts. So the next time you encounter a problem or a question, remember to use the scientific method.